Hello, my name is Kyla Johnson, and I did my experiment on the improvement of water quality with the use of macrophytes. So just some background information on the experiment. I used duckweed, and duckweed is a macrophyte that tends to be associated with fertile or eutrophic conditions, and this makes it the perfect candidate for this experiment. Wastewater technologies actually really need improvement right now, and a simple and effective step could be to include the use of macrophytes. I focused on nitrogen and duckweed, so that's what we'll discuss in this experiment. So in order to test my theory, samples of duckweed were taken along with control samples and initial samples. They were then left to incubate and then transferred to a lab to test for nitrogen levels. The duckweed samples should have less nitrogen than the initial and control samples in the end due to the macrophytes properties. Water from residential ponds or wastewater treatments typically contain high levels of organic compounds, nutrients, or even pathogens. And the methods for removing these components have become very expensive and strenuous, requiring chemicals and machines, which makes it not only expensive and hard for lower income countries to access, but also bad for the environment. So in order to remove water to improve our water quality naturally, we could utilize macrophytes. And macrophytes include aquatic plants that provide many benefits to the bodies of water they inhabit. And to quote Briggs, macrophytes actually stabilize the surface of beds, provide good conditions for physical filtration, prevent vertical flow systems from clogging, insulate against frost during the winter, and provide huge surface area for attached microbial growth. And applications of specifically duckweed in wastewater treatment was found to be very effective in the removal of nutrient soluble salts, organic matter, heavy metals, and eliminating suspended solids, algal abundance, and total and fecal coliform densities. So based on these few sources that I have used, this experiment should work. This should be a very great alternative to chemicals and machines, at least in the initial process. So the ultimate goal of wastewater engineering is actually to protect the public health in a manner that commensurates with environmental, economic, social, and political concerns. So it's not just about the water, it's also about, is it accessible? Is it going to help the environment, or is it going to deter it? So based on Chaudhary and Sharma's observations, the use of macrophytes such as duckweed may allow for a more natural purification system that can be made easily available even to the poorest of countries. It is necessary to filter wastewater to prevent unpleasant smells, the production of pathogenic microorganisms, the production of toxins, and of course, the reuse of water. Technology has been developed to filter wastewater, but not every country has access to these expensive and technical systems. And due to the lack of proper sanitation in a lot of countries, marine ecosystems are being polluted, specifically by dumping, and this leads to dead zones. And dead zones are areas of body of water where no life exists. And this experiment will determine if the use of duckweed will be able to improve water quality in a cheap and environmental friendly way, so that way we can prevent these kind of things. This experiment, if the results coincide with my theory, this will provide an alternative method for water purification. And this, along with phosphorus, not just nitrogen, but phosphorus as well, are the main cause of eutrophication. So now we'll discuss the methods. This experiment was conducted in Phoenix City, Alabama, and it was conducted indoors using a residential pond located just yards from my home. And I got 14 test cups along with 2 sample bags. 7 test cups and 7 control samples were labeled A through G. 2 bags were labeled as initial tests. 60 milliliters of pond water were put in each cup and bag. Duckweed was collected from a local treatment plant to insert into the 7 sample cups. I gently washed the duckweed 3 times before putting it into the cups because it did come from a wastewater plant. And I only put about a tablespoon of duckweed in each sample cup and try to keep everything pretty equivalent. So 7 samples along with controls were left in front of the window. The initial tests were put into the fridge. I left the samples to incubate over a 7-day period, and at the end of this period, all 17 samples were then transferred to the lab. All the samples were then filtered using a 150 millimeter filter with bowl. And this is an essential step to remove the duckweed and other sediments from the pond water in order to accurately test the nitrogen levels. The equipment was washed thoroughly after each use, so I did not contaminate each sample. And I tested the levels of nitrogen in each sample, starting with an Oakton Ion 6+ pH ion meter, and I'll show you guys a picture of that in the future. And I did this for all the control samples as well as the duckweed samples A through E. And then the equipment experienced a glitch. So I had to switch to cadmium reduction 8171 using a Hawk DR 2800 spectrometer. I also have a picture of that. So this is used for duckweed samples F and G and the 2 initial samples. I inserted the recorded data into an Excel file to determine the average level of nitrogen and the standard deviation. And then I determined if the change is significant using a t-test on JAS software. So here's my equipment used. Over here we have my cups, my test cups. This is the duckweed up here. These are my controls. Here are my initial tests. I did take some extra because I have a cat, and just in case I encountered any issues, I had the same water source to use. And then here we have the filter as well as the bowl. We have the ion meter, and then we have the spectrometer. Now we'll discuss the results. So the samples with duckweed increased in nitrogen levels over the 7-day period. The control remained relatively the same over the 7-day period, and this figure here shows that there is a significant difference between the control and the test group. We have a t-test value for the samples at a 4.6. So that's much higher than our duckweed samples with a 2.7. And then our p-value over here for the controls are 0.004, and then we have 0.031 for the samples with duckweed. So the samples differentiated greatly in their levels of nitrogen. And then we have a figure 2, which shows the standard error for each group has a 4% difference. So we have our mean here, and we see the samples with duckweed had a much higher standard deviation, mean, and it just overall had greater levels of nitrogen, and this was not planned. So this shows the descriptives of the paired samples in the t-test. It shows the sample size, the average standard deviation, and the standard error for each group. On day 6, the duckweed actually began to die, which caused this increase of nitrogen that we are seeing. Notice that the control group does have a lower average and smaller standard deviation, as we have discussed. So now we have this pretty graph here. These are some of our results all put together. We have our control samples, is this orangish color. For yellow, we have our samples with duckweed, and then our initial samples. So our initial samples did not change much at all, really, no error, nothing. But our control samples had a slight change, and then our samples of duckweed had this just like large difference, and this was because the duckweed began to die. So this figure 3 actually shows the samples of duckweed had a higher nitrogen level than the control samples, obviously, and then the control samples had higher nitrogen levels than the initial samples. The initial samples were put in the fridge after they were measured out, and that's why they did not experience as much fluctuation. That's why there are no error bars, no change, because the microbial growth was slowed due to the climate control. But the ones left out in the sun, even the control samples experienced a change because possibly algae in the water was able to grow and produce nitrogen. The control group had a lower average and a smaller standard deviation than the test samples, and the test samples had a higher nitrogen level than the control samples. The control samples had higher nitrogen levels than the initial samples. So there was a 4% increase in the nitrogen from the control to the test samples, and that's pretty significant. And every sample did have floating sediment in it, which we did discuss. That's probably why we experienced in the control samples some fluctuations. We discussed refrigeration allowing for microbial growth to slow. And therefore, the initial group experienced very low levels of nitrogen. The controls had an increase in nitrogen from the initial samples due to the algae-like sediment and being left in the sun. So the test group with duckweed had a 4% increase from the control group due to the duckweed beginning to die. The metabolism of the macrophytes affects the treatment process in different extents depending on the design of the constructed wetlands. And this constructed wetland did not line up with what duckweed needs to survive. So the constructed experiment lacked enough sunlight, lacked enough space to complete its intended processes. The room temperature stayed about 70 to 80 degrees, and duckweed growth rapidly declines at temperatures above 31 degrees to 35 degrees Celsius, which it may not have been optimal temperatures for this experiment. And duckweed requires high levels of sunlight, temperatures below 31 degrees Celsius, and space to grow, and a comparatively long retention time in the range of 20 to 25 days are postulated for duckweed treatment efficiency and we only did 7. So there were some things that I would have changed about this experiment. The 7-day period just wasn't enough to get effective results, and the duckweed was not set up in a good environment. So I just want to note that although polluted, village ponds are a rich source of nutrients like nitrate and phosphate, which is what I was focused on, and this can be recovered by phytoremediation, which is actually the use of plants and aquatic plants and macrophytes. So the results were not conclusive with my hypothesis. Instead, the experiment produced the opposite results. The goal of this experiment was to study the alternative methods for water purification, and this is important for the future of wastewater treatment. And another note, urine constitutes less than 1% of domestic wastewater, but accounts for most nutrients. Typically 80% of nitrogen and 50% of phosphorus contained in wastewater, and this could be removed with the use of macrophytes if it's done correctly. So duckweed would be a great candidate for the removal of nitrogen and phosphorus, just not in this instance. Wastewater handling at treatment plants will become simpler and cheaper because nutrient elimination is rendered unnecessary. It's expensive, and we use chemicals that just aren't necessary. So here I have my references, and then we'll just go over some commonly asked questions. So people may ask, would duckweed survive in every country? Duckweed most likely would not survive in every country unless it was in a controlled environment. That is what's important, is the environment we set this duckweed up in. So there are other macrophytes, such as a water hyacinth, that could also remove nutrients from wastewater. It just really depends on what you want to remove and what environment you have. So there are alterations to this experiment that could be done. Another commonly asked question would probably be, will machines and chemicals still need to be used? Machines may still need to be used in order to disperse waste, but harmful and expensive chemicals could be avoided with this use of macrophytes. It would be doing the same thing the chemicals would. It's just more natural and better for the environment. So how effective is this really? This is a very effective method. There have been tons of studies on it, and it's strictly for wastewater. There have been many studies on this method, and I believe personally that the time we implement these studies, and if we implement these studies into our everyday lives for the sake of our environment, and the people in less fortunate countries could benefit, could really help us. So thank you for listening to my presentation.